Hello everyone. Today we're going to be talking about using systems of equations to solve word problems, a flip lesson. So just to keep in mind, if you're not familiar with flip lessons or how they work, you can take notes on what you see. Similar to in class, the notes will be highlighted in blue in a few slides from now. At any point, obviously, you can pause the video. If you want to practice something without seeing me talk about it or me actually doing the work, feel free to pause it and do it yourself and then check. Write down any questions you have. This way when you come to class the following day, we know where to start from. And obviously you could rewatch it as much as you'd like. Okay, so with word problems, we're going to be using some of the strategies we've used so far with solving a system. The only difference is we're going to have to apply something. We're going to have to pretty much create the system. But first, it's important that we review our three methods for solving. Number one, we can solve a system graphically. That was the very first one we did in class. We can graph two linear functions, either in standard form or slope-intercept form, and we're basically finding the point of intersection, the point that satisfies both equations where they intersect. And that coordinate, that x and y value, is the solution for the system. We can use an algebraic technique of substitution, where we could solve for one variable, substitute it in the other equation. You wouldn't want to substitute into the same equation. Substitute into the other, and then you're eliminating a variable pretty much, so you could solve a one variable equation and then take that answer and find the other value by substituting once again. And a third and final technique, as we remember, our elimination method, where we line up and we're trying to create additive inverses. This way, when we combine the equations, we can literally eliminate a variable, creating a one-step equation that we could solve pretty easily. We might have to multiply by a constant at some point if there isn't an inverse involved, and sometimes we might have to multiply both equations by a constant to make that inverse for either x or y. All right, so now that we're familiar with how we solve systems again, let's take a look at a sample word problem. So as you can see here, there is no system given. There is no two equations. So that's going to be one of the first things we try to do. We're trying to create a system, and once we have it down on paper, then we could solve it. So it says the sum of two numbers is 14. If 3 times the first number is added to 2 times the second number, the result is 34. Find both of these numbers. So if I'm creating equations, I'm going to be using a and b, x and y, some variables. I want to identify what they are. So step 1, and remember you should be copying down these steps in blue. Step 1 should be to use let statements. I'm going to use x and y for this example. You could use any letters you like. I'm going to say let x be the smaller of the two numbers. I'm just going to abbreviate number. And we'll call y the larger of the two numbers. This is going to help me when I create my equation. This way I know what I'm talking about myself, and the person grading it, the person looking over my work, knows what x is representing and what y is representing. Okay? And now from here, I'm going to try to translate to create my two equations. So let's take a look at the first sentence. First sentence, all in blue, says the sum of two numbers is 14. So I just represented my two numbers. My two numbers are x and y. The key word in this sentence is sum. Okay? You should recognize that as addition. So that means I can take x plus y, and it's saying it is 14. In other words, it's equal to 14. So we took that first sentence outlined in blue and wrote it as x plus y equals 14. So you can see right away how the variables are useful. Okay, and now since it's a system, I do need a second equation. I wouldn't be able to solve x plus y equals 14. I need two equations. And that's the second sentence. This one's a little bit more wordy, so we'll break it down piece by piece. If you want to start at the end, you can see is 34. So we know we're going to have something equal to 34. And now let's start from the beginning. 3 times the first number, okay, is added to 2 times the second number. The result is 34. Okay, so 3x plus 2y equals 34. And now, I have my system. I can solve this. So, the way this is set up now in standard form, I would probably want to use elimination. You have a few options here. You can do substitution up top. You can multiply the top equation by, let's multiply it by -2. Okay, this way we get, I'm just going to write it right underneath it as a matter of fact. Negative 2x minus 2y equals negative 28. I'm basically canceling out my y's because now if I combine these, this works out nicely for x. I'll have 1x, my y's are gone, equals 6. Okay, I don't even have to divide here. X is 6, I'm all done. Okay, to find y. We can plug into one of these original, I'll probably plug into the first equation we created in blue. So we now know it's 6 plus y equals 14. You can do that mentally. 6 plus what is 14? Or if you just subtract 6 from both sides, it could be y equals 8. Okay? When I have let statements, I like to go back up top and kind of write it in. This way I'm not misidentifying something if there's another aspect to the problem or if I have to do something else with it. So my two numbers here are 6 and 8. And it might have been a little bit more clear if we just labeled them as first number and second number, being that we didn't know which one was smaller or larger from the start. But however you identify them, just make sure that you incorporate a let statement in the beginning. Something like let x equal the first number, the smaller number, and y equal the larger number. Okay, and we've answered the question. We found both numbers. We used elimination. Like I said, we could have used substitution. Graphically is also an option. Not that it probably wouldn't be very useful here. You have quite a large y-intercept. And you can check that the answer makes sense. A lot of times with word problems, you might be dealing with money or finding a population. You want to check that your answer makes sense in context. If you're doing a population question and you get a decimal, you know you made a mistake somewhere. If you get some crazy number that doesn't really apply real world, you also know you made a mistake. So just mentally check your answer and also obviously check they didn't make any algebraic mistakes throughout the problem. Okay, at this point, if you'd like to pause it, very similar to the example we just did, you could try this example. So start with your let statements, create a system, and solve it. I'll be in the process of working it out, but like I said, if you'd like to pause it, copy down the example, and get started, go ahead right now. Okay, so a little bit more clear here. We don't know which one is smaller or larger. We just say let x be the first of these two numbers, let y be the second of these two numbers. All right, in this case, we're talking about the difference. So the difference between them is 10. Similar to where we had the sum in the first problem, now we're talking about a difference. This tells us to subtract. And when 3 times the first number is subtracted from 3 times the first number is subtracted from this piece right here. We talked about this with polynomials earlier in the year. This can be a little bit confusing if someone directly translates this, but the 3 times actually goes to the end of this statement because we're subtracting it from 4 times a second. So it actually begins with a 4y because that's what we're subtracting it from. And we're taking away 3x, which is 3 times the first, is 38. Okay, a few ways to do this. Once again, you can use elimination, substitution, graphing. Being that we used elimination on the last example, let's try substitution here. I would solve for x, so we get 10 plus y, and then we can replace x in this bottom equation. I want to use parentheses here, 10 plus y equals 38. I could distribute. Okay, I'm just going to slide over to the left. Combining my like terms, I'm going to have 1y. So we get lucky once again, we don't have to divide here. I'm going to add 30 to both sides. Okay, and I get that. And now, so I get 1y equals 68. I do not have to divide. I can plug in to find x, and x would be x minus 68 equals 10. Add 68 to both sides, and get x equals 70. Okay, so your two numbers here should be 68 and 70. Okay, and once again, you can check by plugging in, check it in context, check that it makes sense. You don't need to make any substitution or elimination errors. At this point, now that the video is over, again, feel free to go back, watch if you missed anything, make sure you have the notes down. If you want to see the problem again and focus on a different angle of it. Also, make sure that you fill out the Google form below in the comment section. This way I can keep track of who's watched this and who hasn't yet. Okay, any questions, jot down your notebook right now as well. This way you don't forget when you come in tomorrow. Okay, thank you for watching everyone, and I'll see you guys in class tomorrow.